Hi everyone, myself Dinesh, working as assistant professor from the Department of Mechanical Engineering, SNS College of Technology. So this is the third video, okay, of introduction to flexible manufacturing system. In the first video, we have seen the definition on why FMS is required, followed by the overall structure of FMS. That means the mind map of FMS in our second video, okay, and also we have seen the empathy part of the FMS. So why FMS is required in this modern manufacturing system. Uh, okay, so this is our third video. Here we are going to see the defining the manufacturing cell. Okay, now let's take a problem statement first in order to understand it very clearly. How can a manufacturing system, okay, handle multiple product variants effectively with minimum setup time while maintaining quality and throughputs? Okay, so this is the problem statement. So the problem statement itself clearly state that we need FMS in order to handle the varieties. Okay, so the FMS cells are more flexible when it's compared to the traditional manufacturing system. Okay, so now the design constraints, for example, medium production volume. Let's say a product which we produce 100 to 10,000 units per year, we can call it as a medium production. Medium production variety means 10 to 100 part types. Okay, so quick changeover requirements uh, uh, must be taken in minutes, not in hour, because if it takes in hours, it will go for more downtime. Okay, so the quick changeover requirements should always be calculated in minutes, and it has to be completed within in the minutes itself, not in hours. Then the quality consistency across all variants. Okay, so now let's take an example, automotive supplier. Okay, an automotive tier 1 supplier manufacture transmission gear for 5 different vehicle platforms. Each platform required 8 to 12 unit gears, types. Okay, here it mentioned types with varying tooth profiles, sizes and materials. So traditional manufacturing requires 2 to 4 hours of setup time between different gear types, limiting daily production to just 2 to 3 variants and creating inventory bottlenecks. Okay, so it's clearly stated these are the places where FMS can be used effectively. Okay, so the ideation phase, that means the generating solution, first group technology. Okay, classifying part into families based or similar manufacturing process, allowing effective or efficient production planning and reduce setup complexity. Okay, then CNC machines with tool changes, followed by automation, material handling and centralized computer controls. Okay, these are all the things which have a major part in FMS. Okay, so here also, if we take an example, a precise machining company implements a flexible CNC cell with 4 machining centers connected by an AGV system. AGV works as material handling. Okay, the cell can produce 15 different aluminum housing components for industrial pumps. Okay, setup time reduced from 90 minutes to just 8 minutes through automatic tool changing and part program selection. Okay, so in this implementation, we can clearly understand that the time is reduced and also the quality of the products is not changed, and the overall productivity is also increased if we are going to implement FMS. Okay, so building the prototype system, it consists of raw input, automated transform, process station, and stage of outputs. Okay, so these are all the main things when it's come to the prototype system. And when it's come to testing and validation, machine utilization is 85 percentage. Average setup time must be